7144. If an individual has gone scuba diving, which has required an ascent, and will be flying to cabin pressure altitudes of 8,000 feet or less, the recommended waiting time is at least A. 8 hours, B. 12 hours, C. 24 hours. The correct answer is C. Scuba diving involves exposure to increased pressure underwater, which leads to the absorption of nitrogen into body tissues. During the dive, as the diver ascends, the gradual reduction in pressure allows the excess nitrogen to be released safely from the body without causing decompression sickness. However, even with a required ascent during the dive, there may still be residual nitrogen remaining in the body's tissues. Flying to cabin pressure altitudes of 8,000 feet or less after scuba diving can expose the body to reduced cabin pressure, which could lead to the formation of bubbles and potentially cause decompression sickness. To reduce the risk of decompression sickness during air travel after scuba diving with required ascent, a more conservative waiting period is recommended. The waiting time of at least 24 hours allows for sufficient elimination of any residual nitrogen from the body's tissues. This waiting period gives the body ample time to off-gas the excess nitrogen and reduces the likelihood of experiencing decompression sickness during the flight. It's important to note that the recommended waiting time can vary depending on several factors, including the depth and duration of the dive, the individual's health and fitness, and the specific dive profiles. Some diving organizations may suggest longer waiting times for more conservative dive practices or dives involving significant depth or multiple dives. It is essential to prioritize personal safety and adhere to the recommended waiting time after scuba diving with required ascent before undertaking air travel. Consulting with a diving or aviation medical specialist can provide personalized advice based on the specific dive parameters and individual circumstances. They can provide guidance on the appropriate waiting time to ensure a safe transition from diving to air travel. 7156. During a climb to 18,000 feet, the percentage of oxygen in the atmosphere A. increases, B. decreases, C. remains the same. The correct answer is C. Atmospheric composition refers to the relative proportions of gases present in the Earth's atmosphere. The composition of the Earth's atmosphere is approximately 78% nitrogen, 21% oxygen, and the remaining 1% consists of various trace gases, including argon, carbon dioxide, neon, helium, and others. During a climb to 18,000 feet or any increase in altitude, the overall atmospheric pressure decreases. This decrease in pressure is primarily due to the reduced weight of the air above as altitude increases. However, the relative proportions of gases in the atmosphere remain relatively constant. Therefore, the percentage of oxygen in the atmosphere does not change during a climb to 18,000 feet. It remains around 21% at all altitudes. This means that, on a molecular level, the air is still composed of approximately 1/5, 21%, oxygen molecules. However, while the percentage of oxygen remains the same, the reduced atmospheric pressure at higher altitudes affects the availability of oxygen for breathing. As altitude increases, the reduced pressure decreases the number of oxygen molecules in a given volume of air. This decrease in the density of oxygen molecules leads to a decrease in the partial pressure of oxygen. The reduction in oxygen availability at higher altitudes can have physiological implications, particularly for humans who require oxygen for normal bodily functions. As altitude increases, the reduced oxygen availability can result in hypoxia, which is a condition characterized by inadequate oxygen supply to the body's tissues. To ensure adequate oxygen levels for proper physiological function at higher altitudes, pilots and individuals may need to use supplemental oxygen. The use of supplemental oxygen helps compensate for the reduced oxygen pressure at altitude and maintains the necessary oxygen levels to support normal bodily functions. In summary, the percentage of oxygen in the atmosphere remains constant at approximately 21% during a climb to 18,000 feet. However, the reduced atmospheric pressure at higher altitudes affects the availability of oxygen, necessitating the use of supplemental oxygen to maintain adequate oxygen levels for human physiological function. 7157. Which statement concerning hypoxia is true? A. Belligerence or a false sense of security may be symptoms of hypoxia. B. Hypoxia is caused by nitrogen bubbles in the joints and bloodstream. C. Forcing oneself to concentrate on the flight instruments will help to overcome the effects of hypoxia. The correct answer is A. Hypoxia refers to a condition in which the body is deprived of an adequate supply of oxygen. It can occur when flying at high altitudes where the oxygen concentration in the air is reduced. Hypoxia can have detrimental effects on cognitive function, decision-making, and overall pilot performance. Belligerence, or an aggressive or confrontational behavior, is one potential symptom of hypoxia. As oxygen levels in the body decrease, it can affect brain function and lead to changes in behavior, including irritability, mood swings, or even belligerence. On the other hand, a false sense of security is another possible symptom of hypoxia. As the brain becomes deprived of oxygen, cognitive abilities can become impaired, leading individuals to feel overly confident or complacent, even when facing potentially dangerous situations. It is important for pilots to recognize these symptoms and be aware of the possibility of hypoxia at high altitudes. The effects of hypoxia can impair judgment and decision-making, making it challenging to self-assess and identify the symptoms. Therefore, pilots undergo training to recognize the signs of hypoxia and use supplemental oxygen to maintain adequate oxygen levels at higher altitudes. To overcome the effects of hypoxia, it is not sufficient to force oneself to concentrate solely on flight instruments. Instead, it is crucial to address the root cause by ensuring sufficient oxygen supply to the body. Recognizing the symptoms, using supplemental oxygen, and descending to lower altitudes are appropriate actions to mitigate the effects of hypoxia and ensure the safety of the flight. 7159. What physical change would most likely occur to occupants of an unpressurized aircraft flying above 15,000 feet without supplemental oxygen? A. Gases trapped in the body contract and prevent nitrogen from escaping the bloodstream. B. The pressure in the middle ear becomes less than the atmospheric pressure in the cabin. C. A blue coloration of the lips and fingernails develop along with tunnel vision. The correct answer is C. When flying at high altitudes, the air pressure decreases, resulting in reduced oxygen availability. Without supplemental oxygen, the body may not receive an adequate supply of oxygen, leading to a condition called hypoxia. One manifestation of severe hypoxia is cyanosis, which refers to a bluish discoloration of the skin, particularly in the lips and extremities such as the fingernails. Cyanosis occurs when there is insufficient oxygen in the bloodstream, leading to a change in the coloration of these body parts. In addition to cyanosis, occupants experiencing hypoxia may also develop tunnel vision. Tunnel vision refers to a visual impairment where the peripheral vision becomes restricted, resulting in a narrowed field of view. It can affect an individual's ability to perceive their surroundings accurately and can potentially hinder critical decision making and spatial awareness. These symptoms, including cyanosis and tunnel vision, serve as warning signs of hypoxia. Recognizing these signs and taking appropriate actions, such as descending to lower altitudes or using supplemental oxygen, is crucial to mitigate the effects of hypoxia and ensure the safety of the occupants during high-altitude flights without pressurization and supplemental oxygen. It is essential for pilots and passengers to be aware of these potential physical changes associated with hypoxia and to take necessary precautions to maintain adequate oxygen levels in their bodies during high-altitude flights. 7158. Hypoxia is the result of A. Excessive nitrogen in the bloodstream. B. Reduced barometric pressures at altitude. C. Decreasing amount of oxygen as your altitude increases. The correct answer is B. Hypoxia refers to a condition in which the body tissues are deprived of an adequate supply of oxygen. It typically occurs at higher altitudes where the atmospheric pressure decreases. As altitude increases, the barometric pressure decreases due to the reduced weight of the air above. This reduction in barometric pressure leads to a decrease in the overall density of gases in the atmosphere, including oxygen. With lower atmospheric pressure, the amount of oxygen available per unit volume of air decreases, resulting in reduced oxygen partial pressure. The reduced barometric pressure at altitude affects the exchange of gases in the lungs, leading to a decrease in the amount of oxygen that enters the bloodstream. Consequently, as altitude increases, the amount of oxygen available for the body's tissues diminishes, resulting in hypoxia. To mitigate the effects of hypoxia at higher altitudes, aviators and individuals in aviation or mountaineering activities may use supplemental oxygen to maintain adequate oxygen levels in the body. Supplemental oxygen helps compensate for the reduced oxygen partial pressure at altitude and ensures sufficient oxygen supply for normal physiological function. Understanding the relationship between hypoxia and the reduced barometric pressures at altitude is essential for pilots and individuals operating in high-altitude environments. It allows for proper precautions to be taken, such as using supplemental oxygen or descending to lower altitudes, when necessary, to mitigate the risk of hypoxia and maintain safety during flight or other activities conducted at high altitudes.